Allow me to share my screen. Please let me know if you can see the slide on presentation mode.
On slideshow, miss.
Yes, is it on
I
slide?
think wala, miss. Ay lang siya sa, ano, sa PowerPoint mismo.
Can you see it already in slideshow?
Yes, miss.
Okay, thank you. Now we are reviewing. I will have a quick review on numerical integration. So in here, your objective is to be able to approximate the values of definite non-elementary integrals using the methods that we have discussed. So we have discussed trapezoidal rule and Simpsons rule. As two examples of non-elementary integrals, so you have here 12. And these are integrals which cannot be evaluated using the techniques that we have covered last term, that's midterm. So they cannot be processed since they are indefinite, so they cannot be processed using the techniques and the formulas that were shared to you in the previous term. So as such, even if you're going to place here limits to make these indefinite integrals definite, we won't still be able to give its value. So we need a tool to approximate the value of these non-elementary definite integrals once they have limits. In your calculators, if you're going to have these integrals inputted and then just place the limits, your calculators actually can answer it. But let's say, what if you'll be the one to uh, illustrate how the indefinite integral is to be evaluated, and after you are to show the answer after substitution of limits, then it would be near impossible for you to do that because these are non-elementaries. So integral. So that is why we have to know the following methods of approximating the values. So we have trapezoidal rule and Simpson's rule. So in trapezoidal rule, you are approximating the value of the integral by comparing the area of that particular integral to the area of the trapezoid included in the area of such a function. So in here, if this is your function to be integrated, and to find the value of the integral, it's equivalent to finding the area under the said function bounded by the limits of the integral. You will approximate it by simply determining the area of this trapezoid. Now, it could be done this way with just one trapezoid. It could be done this way in which you have two trapezoids. And it could be done this way in which you have three trapezoids. So generally, we can have a more generic formula that will allow us to approximate the value of a definite non-elementary integral using the trapezoidal rule. And that particular formula is this one. So I'd like to annotate here just to emphasize. So in this particular formula, I'm referring to this. You have h divided by 2, where h is the x sub n minus x sub o divided by n. Your x sub n is the upper limit of the integral. Let's say it's letter b. And your x sub o is the lower limit of the integral, which is a. And n is your chosen number of divisions or intervals. So this is your intervals or number of divisions. Now this each should be divided by 2, and you are to multiply the value of h divided by 2 by this expression here. So depending on how many intervals you use. As long as in the formula that you are to take the summation of the first term and the last term will not have any multiplier. So your function, the f here that is being referred to, if I may say, is the integrand. This function here that appears in your integral. That's the function evaluated. This x sub o is your a. This one is the function evaluated when x, your variables, is equal to b. Now, what about the function here in the middle? These are the function values after you have incremented a by the value of x sub n minus x sub o divided by n. Whatever is the value of this one, that would be the increment that you're going to increase the value of x sub o, or that is a, until you reach x sub n. Now, the middle terms need to be multiplied by 2. So you can see here you have a multiplier of 2. So this is your formula for the trapezoidal rule. Anyway, it's just a review. But nonetheless, if you have questions, don't hesitate to interrupt me. Now, in terms of an example, so this is how it's done. Let's say I will just pick one here. You're going to use the trapezoidal rule in approximating the value of the integral of sine of x evaluated from 0 to pi using 6 subintervals. Number 1. So since we're using 6 subintervals, that would also represent our n, and our increment, the h, would be b minus a divided by n. So that would be pi minus 0 divided by 6. And that would be pi over 6. Now, this pi over 6 will be the value in which you are going to increment the variable starting from the lower limit up to the upper limit of your integral. So let's say these are your increments. So in the first one, you haven't incremented yet. So it's increment 0. Then, of course, the value of x sub I, since you haven't incremented yet, is your lower limit, which is 0. Okay? Now, you have 6 divisions. So from 0 increment up to 6. So you place here 6. Then you increment starting from 0 by pi over 6. And that is your value of x you need to increase by pi over 6. So pi over 6 plus pi over 6 is 2 pi over 6 plus pi over 6, 3 pi over 6 plus pi over 6, that's 4 pi over 6 plus pi over 6, that's 6 pi over 6 plus another pi over 6. That would be 6 pi over 6, and that is pi. So they really coincide because on your last increment, in your last subinterval, which is the 6, you have the upper limit already reached, which is pi. So they should coincide. The last increment should give you the upper limit of your integral. Now, what should you do with these values of x which you incremented by pi over 6? You will substitute it to the x here that appears in your integrand, or in the function that appears on the right side of your integral. So you just evaluate this, sine 0, sine pi over 6, until you reach sine pi. Now, since your values here are not degree values, don't commit that very grave mistake of having your calculators in degree mode. It should be in radian mode. Okay? Now, since you already have the functions here, you know that the value of this will stand as is. The same thing with the value of the sine of pi. This would also be as is. Whereas the values here of these functions here, 1, 2, 3, 4, 5, will be multiplied by 2. So this is your f sub 0, this is your f sub 1, f sub 2, f sub 3, f sub 4, f sub 5, f sub 6. F sub 0 and f sub 6 doesn't have any multiplier. F sub 1 to f sub 5 needs to be multiplied by 2. So if you recall last meeting, we had reached this value, which is 1.9540. Now, the error as discussed with you is the absolute difference. Absolute meaning the sign is not important. It's the absolute difference of the value that you have here in your approximation minus the value of the integral when processed using your calculator. And that is you did not use any approximation technique. You divide it by this actual value because this one, when processed in your calculator, will be more accurate. So the error computed should be 2.2951. Now, any question? Okay, so this is just but review anyhow. So we'll go to Simpsons rule. So Simpsons rule. If trapezoidal rule approximates the area under the function to be that of a trapezoid, in the case of Simpsons rule, though you have also here two parallel sides for the figure that needs to be computed in terms of its area, but this side here is not a line, but it's curved. Okay? It's not a line because if this is a line, then this would be a trapezoid now. So you have a curve. So if you notice, class, in terms of which of the two will have the lesser error, I think it would be the Simpsons rule because you have a curve here, not a line. Just like this one, if this is a line, it would only be from this corner to this corner here. You won't be able to include this area. So Simpson's rule is only, however, applicable to even sub-intervals. So meaning, trapezoidal rule can use 5, 11, 13, 2, 4. No limitation as to the number of divisions or sub-intervals or number of areas that you need to sum up. That way, you can come up more or less of the area of your curve. In Simpson's rule, it has to be even. So n has to be even. Nonetheless, the approach is still the same. They only differ in the formula. So for one, I'll go to the, this formula is only good for for two divisions. And the other formula is good for 4 divisions. You have this, so it's even more accurate. And the formula would be this. But let's say we'll have even numbers for n, any even number n. What would be the more generic formula to use? That formula would be this. So one major difference between the formula for trapezoidal rule and Simpson's rule is the division that you have here. Trapezoidal rule is divided by 3, Simpson's rule is divided by trapezoidal rule rather is divided by 2. Simpson's rule is divided by 3. So you could see here 3. This delta x is still h. So it's the h in your trapezoidal rule. Another thing is that though you have the first and the last terms having no multipliers, in the middle terms, you need to alternately multiply the value of your function by 4 and 2. So 4, 2, 4, 2, 4, 2, 4, 2. Your second and your second to the last term should have 4 as their multiplier. As such, it's important that your number of divisions or sub-intervals should be even in the case of Simpson's rule. Okay? Now, if we'll have a sample problem for this one, so let's say this one. So you have now a non-elementary definite integral. Your function actually is 2,000 ln of 140,000 divided by 140,000 minus 2,100 t minus 9.80. So this is a non-elementary integral, a definite non-elementary integral. And without your calculators, you won't be able to evaluate the value of this if not for these two methods. So if you're going to use Simpson's rule here, Simpson's rule, then your formula will be something, sorry, let me just accept your classmates. So your formula would be something like this, okay? You are to determine the distance covered by a rocket in meters starting from 8 seconds to 30 seconds. So the distance the rocket covers 30 seconds after launching and until 30 seconds. Okay? Your A plus B divided by 2 is 19. And in here, your number of division is just 2 because you could see that you have 6 here And in terms of the formula, it's actually delta x divided by 3. So since it's divided by 3, then the n that you had used for your delta x is just equal to 2. So you have 3 times 2, that would be 6. Okay, now as to how it's done properly, so in here the number of divisions is just 2 class, it's just 2. The same thing with, oh sorry, just clear my markings. The same thing with trapezoidal rule. You determine the value of the function. This is your f of a. This is your f of b. Oh, sorry. Why is it not writing? F of b. Let me erase this. This is your f of b. This is your f of a. And this is the middle term, which will have a multiplier of 4. Okay? Now, how will you increment the lower limit? In this case, your lower limit is 8. So that is why you substituted 8 here. You incremented it using the delta x equal to b minus a divided by n. This is actually the h. So you have b being, what's the b in this case? 30 minus 8 divided by 2. So 22 divided by 2, that is 11. So you need to add to your 8. This is 8. You need to add, so your x here would be 8 plus 11, that would be 19. And plus 11 here, this would be 30. So this is the formula that you applied to that specific problem of ours, which only made use of 2 sum intervals in determining or approximating. So I'd like to use the term approximating the value of the distance covered by the racket, which is mathematically modeled using a definite non-elementary integral. So it's all about the formula class. Just substitute everything on the formula and you won't get lost. So this is the distance covered by the bracket. Okay. Now, on a final note, the accuracy of your answer is dependent on the number of divisions or sub-intervals that you have used. Okay, John Vincent, you're raising your hand.
Miss, may I ask if sa tanan nga middle term, miss, may a plus b gid na, miss, always over 2?
Direho.
Miss, for all the middle terms.
This is only for your Simpsons rule, which
Miss.
uses n equal to 2. Only for the Simpsons rule, which uses n equal to 2, because you only have 2 divisions here. But if you're going to apply, actually, this one is just an alternative, ha? Para hindi ka mo mag-memorize, bala? Ini siya, ho? Para hindi nyo ni siya pag-memorize kung ano ang value nga i-substitute sa variable, sa function, always follow the increment formula. The delta x or the h, which is equal to b minus a divided by n. Okay? Now, in our case, our b, our upper limit is 30. Our lower limit is 8. We divide it to 2 sub-intervals. So that would be 22 divided by 2. That would be 11. This is our increment. Our first value, the first value of the function, if actually we have a table, the first value, the 0 value with no increment yet is 8. With the increment, that would be 19. With the other increment, you add another 11, that would be 30. So this is just, let's say, for example, a more direct formula for determining the value of the variable for Simpsons rule only, for Simpsons rule which has 2 divisions. So pwede siya diretsahon amo ni. Pero actually nga amo na siya, dili gini siya gyapon naghalin that you will start with the lower limit of the integral, then you're going to increment it based on the value you have computed, which is 11. And that's your 19. In this case, amo man gyapon. So you have 30 plus 8 divided by 2. And that's 19. Did I answer your question?
Yes, miss. Thank you.
Sige, sige. Para bala to avoid confusion, although you can specifically emphasize, you can specifically tell your brain that this is only good for this particular scenario para wala ka damo sa uluhon, amo na lang ni. That you will increment using this particular formula starting from the lower limit until you reach the upper limit of your integral. In that case, you won't have to really take note whether I'm using trapezoidal rule or Simpsons rule, because whichever of the two methods you use, your increments will still be this way. It should be computed this way. And the process of adding this value to your x that should be substituted to your integrand would be the same, whether we're talking of trapezoidal rule or Simpsons rule. The difference lang man sang duha is ang formula. Kaya ang formula sa trapezoidal rule lain kaysa Simpsons rule. But as to how the function values are determined, exactly the same. Pareho lang, gina-increment mo, tapos gina-substitute mo ang value sa resulting variable sa integrand or sa function that appears on your integrand. Okay, some more questions? So this is what I've mentioned a while ago. So the more number of subintervals we use, the more accurate is our answer. Have any questions? Okay, so there's none. Let me check. I'll stop sharing here. For this topic of areas of plane regions, these are your learning objectives. So at the end, students should be able to find the area between a curve, the x-axis, and two given ordinates. Now, the two given ordinates that is stated here is the limits of your integration. So you are going to determine the area bounded by your curve, the curve of the function that is, the x-axis, and the two given ordinates, which are the limits of your integral. Now, the second thing that you should be able to do is also find the area between a curve and the x-axis where the ordinates are given by the points where the curve crosses the axis. So this time, the area that you're going to determine will be bounded by the intersection of the curve and the x-axis. So wherever your curve or the function crosses the x-axis, that would be the, shall I say, the endpoint or the limit of that particular area. So in this case, it's very important that you know how to find the point of intersection of your function, that is your curve, and the x-axis. The last part is you should be able to determine the area this time between two curves. So if it's the area between two curves, it's also very important that you should be able to find the intersection of these two curves, because this said area will be bounded by the intersection of these two curves. Okay, so we do this one step at a time, but these are your learning objectives for areas of plane region. Now, let's have a short review on the definite integral, although we have discussed it already in numerical integration, how the definite integral could be illustrated as the area under the curve. So let the function be a continuous function on a and b, the interval a, b. Then Riemann sum of the function on a and b approach a real number limit I as n approaches infinity. Now, this limit I of the Riemann sums for the function on the interval AB is called the definite integral. we say n approaching infinity here in the definition because your n, your subintervals could be as many as you want it to be. That way, the area that you are getting is close to the area under the set curve of your function. Now, so that area is actually, the area that you're determining is the value of this definite integral. The function integrated from A to B. The integrand is said to be f of x, and the lower limit is A, and the upper limit is B. That's just a short review. Now, what are areas under functions? So these are definite integrals. So definite integrals here are used to find the area between a function and the x-axis. The limits are the points at the start and the end of the area you are asked to find. So if the curve is drawn, or if the curve is not drawn for you, it is often a good idea to sketch it to give you an idea of what you are looking for. So this is what I mentioned before our discussion, that it is very important that you know how to sketch a curve. That way, if that particular curve will be bounded, let's say, by the intervals or by the limits of your integration, you have a clear picture of the area that you're trying to solve using the process of integration. So that's important that you know how to draw your curve. Now, let me proceed. Is my slide not moving? Now, let's say for example, in here, you are to integrate and substitute in the limits the integral of x squared minus 6x plus 11 on the limits 1 to 4. Just give me a minute, class. This is your curve. Y equal to x squared minus 6x plus 11. This curve is actually a parabola that opens upward. So it's very important that you know how to plot the said curve. That way you have a clear picture of the area that you are determining. So this is your curve. This is the x-axis, and this is, or these are rather your limits of integration. If I will annotate, this is your x equal to 1. This is 1. And this is 2, 3, 4. And this is x equal to 4. So remember that this x equal to 1 is a line that is vertical. So actually, this is the line x equal to 1. This x equal to 4 is another line that is also vertical, and you have this line here for x equal to 4. Now, you could see that in terms of the objective, the learning objectives, this is the first objective that we need to know. Finding the area bounded by the curve, the intervals or the limits of integration, and the x-axis. Although when you find the value of this particular integral, there's no need, you are not required to find the, rather to draw the said area. You're just simply going to find the value of this definite integral, but actually, the value of this definite integral is this shaded in yellow area. Okay, so the area that you're trying to find in here is actually the value of this definite integral, bounded by the integrand, the limits of integration, these two, and the x-axis. So it's just very easy. All you have to do is evaluate, then substitute your limits. This would be for the upper limit, and this would be for your lower limit, and the resulting is this. So the area under the curve x squared minus 6x plus 11 is 9 units squared. So it's squared because, you know, if we're talking about area, it's either meter squared, feet squared, all those linear units which is being squared. Now, I will continue if you don't have any questions here. Any questions so far? Okay, so that's for our first example. Let me proceed. Now, what about for the second example? So, integrate and substitute in the limit. So, this time, your function is x cubed minus x plus 3. That particular function class, if plotted, would be this curve. Okay? X cubed minus x plus 3. It is bounded by the line x equal to negative 1 and x equal to 1. So this is your x equal to negative 1 and this is your x equal to 1. Now you are to find the area bounded by these two vertical lines and this function, of course, and with this horizontal x-axis. If you evaluate this integral, you will just simply use power rule. You can see you're using power rule for the first two, and you're just simply using here the integral of a constant. And just simply add there the variable x. Then integrate the limit, the answer from negative 1 to 1 should give you the answer, which is 6 units. So meaning this area class is 6 units. That's it. That's how when you find the area, you are actually, or when you find the integral value based on a particular specified interval, you are actually determining the area under the curve, as discussed under also numerical integration. Any question? Yes, John Vincent.
Miss, are we required to do the graphing, Miss, before
No,
we?
no, you're not
Okay,
required
okay,
to do
Miss.
the graphing because in this case, it's very simple. You're simply to find the area of this curve. So there's no need for you to draw. But there are instances that you need to draw. That way you have a clear picture of the area that you will determine. I'm still starting with the simple ones. You need not draw the curve and you need not draw the intervals like this. But in some instances, there's a need for you to draw because you need to specify the points of intersection. For now, there's no need for you to specify the points of intersection because we're still talking about learning objective number 1. Determining the area bounded by the curve, the intervals or the limits of integration, and the x-axis. So there's no need for you to plot if there's the concern. That is based on the first objective. Now, I'll go to the next. Now, beware when you determine the areas, beware curves that go below the x-axis. Now, if you are to determine the area of a function in which a portion of it goes below the x-axis, you must calculate where the function crosses the x-axis. You calculate the area above and below the x-axis. Take note separately. So if you have a function, so this is where now the necessity of drawing the function. Because if the function crosses the x-axis and a portion of it is found below the x-axis, the manner of determining the area should be separate class. You determine the area on top of the x-axis and determine the area below the x-axis and then take the sum of the two. Not that you're simply going to get one, not that you're just simply going to evaluate one integral through and through. Now, that would be illustrated by this example. Now, this one did not be done in the previous example. Hindi siya, you calculate the area above and below the x-axis separately because in the previous example, the area that we're talking about does not fall below the x-axis because your curve is here on top of the x-axis and there's no curve in here below already. Okay, so this is just the area that we're trying to find. Now, what about in cases wherein your area is above and below the x-axis? Let me illustrate it with this. So that's the reason why at times it helps to plot the function. Like this one. Let me check. Okay. Now, if f of x is positive for some values of x on AB, this is A to B, and negative for others, then the definite integral symbol will be the function integrated from A to B, represents the cumulative sum of the signed areas between the graph of f of x and the x-axis, where areas above are positive and areas below are negative. Now, in the case of our curve, this is our curve, right? Example, ano siya ha? This is our curve. We plotted it. These are the limits of integration. This is your lower limit. This is your upper limit. Now, what happens? The areas that you see that is bounded by your curve and the limits of integration are separated into two regions. There is one region that is below the x-axis and one region that is above the x-axis. You cannot just have one integral here for the entire function because it will not solve the sum of these two areas correctly. So what you're going to do, class, is you have to determine this part where it crosses the x-axis and determine the area separately of this region using the function equation. But since the area is below the x-axis, you place negative before it. That way, the computed area that you will actually compute is negative. So, ang buwa karon, it will be subtracted from B. So, that way, it will not be negative. You place negative before the A. That way, this will be considered as an absolute value, even though it's negative when processed, and it will be added to this. So, that brings about the question of John Vincent a while ago. Is there a need for us to always plot the curve? If you're going to ask me if you're certain that your curve will not fall or there won't be an area below the x-axis which should be bounded by your curve, then that's okay. There's no need for you to plot. But it is always suggested that you plot your curve. That way you will know whether there's a portion in your curve that is below the x-axis. That necessitates that it's important that you know how to draw the function, the curve of the function. That way you will know whether there's a negative and positive area. In this case, class, there are two things that you need to do first. Number one, determine the point of intersection of this function on the x-axis. So how do you find the point of intersection of this function with the x-axis? If I may ask you, you're done with your geometry, how will you find the point of intersection of this function with the x-axis? What will you do? Let's say this is 2, and let's say this is 20. How will you find this? Or let's say the curve is already given to you, it was drawn like this, so you're happy already because you need not draw it yourself. But nonetheless, since you are to separately determine the values of these two areas using the definite integral, how will you find this x value? The point on the x-axis where your curve crosses. Anybody? What would you do? How will you find this x here? Because you do not know what is this. Unless, of course, the curve will be, or the illustration will make it specific. But if it's not, most of the time it's not, you're the one who's going to determine it. How will you find the point of intersection of your function and the x-axis? Anybody? Hala. Your x-axis, this is your x-axis, right? What is the equation of the x-axis, by the way, if I'm going to ask you? This is your x-axis, this is your y-axis. What's the equation of the line, which is the x-axis? Or what is the equation of the x-axis? I'm going to ask you. Hello. You don't know the equation of the x-axis? The x-axis is the line y equal to 0. Your y here is 0. Isn't it that when you go up, you have positive y? You go down, you have negative y. So right on the x-axis, the equation of that is y equal to 0. Now, what about the y-axis? What do you think is the equation of the y-axis? This line. What is its equation?
Equals 0.
Correct. X equal to 0. So if you want to determine the point of your function which crosses the x-axis, this function equation of yours should be equated to 0 because your y is equal to 0. You equate the function, whatever it is, x squared plus x plus 1, or e raised to x plus 1, something like that. You equate it to 0. The purpose is you will know this point where your curve crosses. Example, this function of x is x squared minus 1. This one, example ko lang na ha. The equation of the function is x squared minus 1. That is the equation of your function. Your function of x is x squared minus 1. You equate it to 0. Then you find x. So x is equal to, x squared is equal to 1. You transfer it here. And what you get of this? X is either positive or negative 1. So you have 2 points of intersection in the x-axis. One is x equal to 1, meaning your curve crosses the x-axis at x equal to 1. And another one is x equal to negative 1. Ari din isa, example abi, if this is where negative 1 is. And ang isa ari din if this is 1. So this is where your curve crosses the x-axis. So ang wado ang muna, example ko lang nahana. These are its points of intersection. Giving the example that the equation is x squared minus 1. So you set y to 0 and determine the value of x. Whatever is the value you are getting, these are the points where your curve crosses the x-axis. Okay? Why do you need to find this particular x? Because your limits of integration for this A curve will be from 2 to x, kung ano man siya i-value. Ang ini naman nga curve is from x to 20. For example, since I place this one at 20. The function is still the same, but the limits that you're using are different. So you separately determine the area A and the area B and get the sum of that. But don't forget to place negative before the area or before the integral of the area which lies below the x-axis. Which again, I'm going back to the suggestion that which again suggests that it's best that you plot your curve. You plot your function. Unless of course you are certain that your function is just above the x-axis. By the way, class, if I'm going to ask a simple question, you are the type of students that you don't want to waste time. Let's say for you, it's a waste of time to know whether there's a portion in my graph which is below the x-axis and above the x-axis. I don't have the time for that anymore. So I just have one question for you. How will you know that your curve will not have an area below the x-axis? What makes you sure that your curve will have an area all lying above the x-axis or found above the x-axis? Abe, you think, how will you know that the area of your curve, I don't want to plot. Maybe I'm that student, I don't want to plot. I hate to plot. It takes time. So then there's just one question that you need to answer. How would you know that the area of your curve is above the x-axis or it has some area that is below the x-axis? Yes, John Vincent.
Is it if miss, all there's no negative value?
Value for what?
For y.
Very good. Very, very good. Meaning, for all values of x, for all values of x on the designated interval of your integral, for example, your integral is from 1 to 10. For all values of x from 1 to 10, like 1, 2, 3, 4, 5, as a set, if you're going to substitute it in your function and your y is never negative, you're sure that the area of that particular curve will lie above the x-axis because the y is positive. But if any, not just one, but several, for example, or just even one value of x results to a y value which is negative, then there's a need for you to plot because you need to know as to what area is below the x-axis and what area is above the x-axis. So see, I have one thinking and attentive student, and I am happy because I have John Vincent who reacts with that. So that's it. All y should be positive for your area to be above the x-axis. Positive based on the interval of integration. So take note of this. Put a negative before that area which lies below the x-axis. And then determine this point of intersection. Any question before I proceed? Okay, then I will proceed. Okay, example 3. Here we go. You have y equal to x times, excuse class. So this is our curve. Okay, the curve y equal to x times x plus 2 times x minus 1. I have a question again. Why do you think it's written like this? I have a question. Why do you think it's written like this? Like it's factored already? Actually, if I'll be the one to give this to you, I will not give it in factored form. So probably I'll write this is x squared, so that would be x cubed. I'll have 2x minus x, so that would be x times x, so that would be x squared. And I have minus 2, so this would be minus 2x. Okay? This would be the, let's say, the function that I will be giving you. Why do you think there's a need for you to write your function equation in this form, the factored form? Why was it written in this manner? What do you think is the purpose? Okay, I'll go back to that question. You think of the answer to that question because you could see here, class, that you are to determine the area of this curve x times the quantity x plus 2 times the quantity x minus 1 bounded by the x-axis. And that's it. There's no limit of integration. Take note, you're just asked to determine the area of this curve bounded by the x-axis and no limits of integration was given. Now, you know how to draw your curve. So let's say it's a given, you know how to draw your curve. So I have a question. Why do you think there's a need for this equation, the original equation, to be written in the right side in factored form? Why is it written in factored form? It
Para mas mabal.
sige.
Para mas mabalaan ay maano easily find ang x-intercept.
Para mabalaan ang x-intercept, correct? Or ang very good because you need to know this one. Okay, let me annotate. You need to know this. You need to know this. And you need to know this. So just like my example a while ago, if you want to know the x-intercept or the points of intersection of your curve on the x-axis, you need to equate this to 0, right? Because your y is equal to 0 on the x-axis. So to know the points of intersection, you need to write this original equation if this is the original equation in factored form. So in factored form, you have this. Now what will happen? You could see that these factors now could be equated to 0 separately to give you the points of intersection. So x is equal to 0. This is it, right? X plus 2 equal to 0. So your x is negative 2. This is it. X minus 1 is equal to 0. So x is equal to 1. So you see the reason why it has to be written in factored form? It's because when you set your y equal to 0 to find the points of intersection of your curve on the x-axis, it would be easy for you to find these points of intersection because in terms of factors, you can equate these factors separately to 0 and find these points of intersection. You get it? You get it?
Yes, miss.
Oh, so anong mata po? Let's say I will have this area as A and I will have this area as B. How will you find the areas? Very, very simple. For A, since it's above the x-axis, you will have the integral. Take nota, your limit is negative 2 to 1. Halin sa negative 2, to 0, not 1. Until only 0. Because it's above the x-axis. And I will write this entire thing. I will have x cubed plus x squared minus 2x dx. Now, what happens to this area below the x-axis? We just discussed a while ago that when it is below the x-axis, it should be written as negative. So, instead of adding, I will place here minus because this area is already negative. Or what you can do is place plus, but still you need to place negative before the integral. Now your limit will be from 0. It will start from 0 to 1. And you need to copy everything. So x cubed plus x squared minus 2x. Okay, sorry, it's crowded here. When you evaluate this integral and this integral, your answer will be actually the same. Amo ni siyang answer, oh. X to the 4th over 4, x cubed over 3, minus x squared. For this one, for the negative 2x. However, for the first term, your limit will be negative 2 to 0. So 0, wala na siya. It's just like you have negative 2. And then for the second term, you will have 0 to 1. So your answer for the first is 8 over 3. For this one, this is 8 over 3. For the second one, is 5 over 12. So if you add the 2, it's 37 over 12. Or that's 3 and 1 over 12. Sige. As an exercise, I'd like you to do that in your seats. This is your answer already for the 2. You will substitute for the first set negative 2 to 0. So meaning, if this is your answer, this will all be 0. Minus, the answer of this is x is negative 2. That should give you 8 over 3. Then this one, the same particular answer will be evaluated from 0 to 1. So your upper limit is 1 and your lower limit is 0. So no need na. Can you do that? Can you check whether you'll be getting 8 over 3 and 5 over 12? I give you 3 minutes for that because all you have to do is substitute the limits here. And check whether you can get an overall area of 37 over 12. So, John Vincent got 8 over 3 for the first with the limits negative 2 to 0. What about for the second one? So, it should be plus negative. They should be negative because it's below the x-axis. And substitute the limits. Let's see what would be your answer. Did you get 5/12? See? What about the others? -5/12. If you substitute the upper limit here, which is 1, that would be 1/4 plus 1/3 minus 1. 1/4 plus 1/3, that would be, I don't have my calculator, so let's say 1/4 plus 1/3, because the other one is minus 1. The answer is -5/12, Renan, but it is to be the negative of that. You see this negative sign I wrote? So that should be +5/12. So that's the reason why whenever your area is below the x-axis, you need to write negative before it. Otherwise, you'll be getting a wrong answer. So it makes it positive already. Did you get it, Renan?
Yes, Miss. Thank you.
Sige. So in that case, you have now 5/12 plus 8/3, and that would be 37/12. So this third example, actually, class, is a classic, it's a very simple example of how integral calculus determines the area bounded by the curve and the x-axis. So in this case, your limits of integration are determined by you. You were the one who determined the limits of integration based on these points of intersection. If you do not know that these points of intersection will serve as the limits of your integration for this area, then you won't know, then the purpose of integrating does not have any essence at all. Wala siya essence. If you notice, in the first two examples, you're just simply integrating. You don't even, there's even no point in plotting the curve because you are provided already with the limits. What about this third example? And there are really instances, and most of the time, if critical thinking skills are to be really developed, the limits of integrations are not given. It is the students who sought or finds this limit of integration and apply the limits to the given integral of the function. Just like this particular example. If I may say, kamo nagpangita sa limits of integration. So, hindi pwedeng, hindi kabalo ka mo mag-plot, hindi ka mo karong kabalo mangita sa points of intersection. Actually, even if you did not plot, you will be able to find the points of intersection. But you don't know, if you haven't plotted, which area is above or below the x-axis. So you won't know, these are my 3 points of intersection. Hindi ay sa ila ang sa babaw sa x-axis o sa dalaw sa x-axis kung wala kung nag-plot. So that's the importance of plotting. You get it? Now, I have one question before I dismiss the class. Example class. You already have these points of intersection of your curve. You know that this curve of yours, this y equal to x cubed plus x squared minus 2x, has these points of intersection on the x-axis. How would you know that it would look like this? Nga muna da siya, nga muna di siya, nga diri manaog, nga lang ini siya masaka. How would you know? Just curious. Or if I will ask you, how will you know that this part of your curve will be here and this part of your curve will be here? You only know these three. And how would you know that you have this and you have this here? What would you do? Yes, John Vincent again.
I think, Miss, you will interchange the, for example, Miss, in -2, we interchange it to positive, and for 1, we change it to -1.
Why? Why would you do that?
Nag-try ko lang, Miss.
Okay.
Ay, hindi, gali, Miss.
Ano be? O, sa iba na be. I would like to know if I still have students like John Vincent and Renan who is with me. Paano nyo ni siya mabala? Ano ini? Nga dira na siya. Kahit kung hindi ka kabalo nga dira na siya, kaya ini siya dira na siya, paano kabalo nga mo na yatsura? Diba? So how would you know that you have a point here? That way, you will just connect Like that. Oh, ara na siya. And then I have a point here. I will go down, then go up. How would you know if I'm going to ask you? Actually, the answer is there. I'll clear my markings, ha? I have these points already. Okay? Oh. How do you know that your curve goes up here? Nga wala sa kapanaog di. Pwede man di ba? Or how would you know nga diri siya, hindi siya magsaka? Kabalo ka lang nga ara na dao may tatlo na da ka point sa x-axis na maagi akong curve. Pero wala ka kabalo sa iya behavior. You don't know the behavior of the curve in between these points and beyond. So let's say, just think simply, how will you know your curve? How will it look like?
Kung positive, miss, ang value integral nila.
Kung positive ang value sa integral nila. Ang question ng iya is, before you even integrated, you need to plot, right? Para mabalaan mo kung diin daang sa babaw kag dalom nga area, i-plot mo din na. Kaya hindi ka kabalo kung diin sa ilang i-negative mo. Kung diin sa ilang i-positive mo. Ang question ko lang, how do you know that it would be here, not here? How would you know that it would be here, not here? How would you know nga amo na iya tsura o hindi amo ni?
Kay tungod sa equation, miss, na ginhata.
Now, what about sa equation?
Kay ang sa x positive 2, dayon ang sa negative 1.
No? How do you know that it should be here?
Sa concavity na, miss.
Sa?
Concavity.
Who's speaking? Di ko makita.
Talorong, miss Renan.
It has something to do with concavity. Let's say, Renan, I'm just asking, simple lang. I know that you know about concavity. There's this test in differential calculus, opening up, opening down, concavity test. Binalipat ka na Renan, sa kadamo-damo, sa gintunan mo, manumdum ka pa na sa concavity test. So I'm just going to ask you, what would you do? What would you do so that you will know that you have here 1 on top and you have 1 here at the bottom? I'm just asking for your simple take on this, not the highfalutin concavity test in differential calculus. Simple lang ako niya, ano? Paano mo ba? Ano may point ka dire? Kag dire. O sige, for concavity test, you need to differentiate, right? O. And the corresponding value of the derivative, whether it's increasing or decreasing, that's when you have it's concave up or down. Nalipat ka na dabi. So ano yung hubrahon? So, wala gid. Ako ya miski hindi ko ya kabalo sa concavity test, ya kabalo ko na gyapon mag-plot miski hindi pa ko gintuloan sa concavity test. Simple lang niya ako ni engineering. I need not know about concavity test in differential calculus. What will you do? Why, get? Diba kinanan yung mabalaan kung ano na diyo, kung gasaka na di siya kung gapanaog. This is negative 2, this is 0, and this is 1. I-substitute ka negative 1. Substitute ka negative 1 dire. O, negative 1. Negative 1 plus 2 is 1. Negative 1 minus negative 1. Negative 2. So, the answer is 2. So, ano di siya sa babaw? Kita niya to. Now, kabalun ako nga may-ari ko sa 0, kag 1, nag-cross siya sa x-axis. Di ano yung behavior niya sa 1? Substitute naman ko di 1 eh. 1 times 1 plus 2, 3 plus 1 minus 1, 0. Wait. Y is 0 for x equal to 1. Ari galing 1. So let's say this is 1. So let's say this is 0.5. 0.5. So this is 0.5. I'll clear my markings class. Let's say this is -2, this is 0, this is 1, so this is 0.5. Substitute ko sa 0.5. So 0.5 times 2.5 times -0.5. So negative na siya, oh. See? Sorry, this is the law. The answer is negative something. Negative pala, computan nyo. 0.5 times 2.5, that's 1.25. Times -0.5, that's 0.625. Are you still with me? Oh, see? Correct si Miss Ali. -0.625. Siyara sa dalom. Okay, kung tina-plot mo na, mo na siya tsura, ikin connect mo lang ang dot. You have one dot here, you have one dot here, you have one dot here, you have one. Yan mo na yung tsura. Amo malaning imo nga interesto ang points of intersection ang area bounded by the curve and the x-axis. Interesting, no? Kanami isang application sa integral calculus on areas only. But it will be more interesting and challenging as we study more next week. Do you have any questions, class? You can use the concavity test. So as Renan is saying, the concavity test. So review that in your differential calculus. But the thing with the concavity test is there's a need for you to differentiate. But if you have no problem with differentiating, then go. So you would know whether the curve is concave up or down on a given interval. Okay? Any questions? I'll stop sharing.